Using the discriminant objective, by the end of this lesson you should be able to evaluate the discriminant of a quadratic equation and use it to determine the number of real solutions the quadratic has. So here we go. If you have a quadratic equation, x squared plus bx plus c, the discriminant is this guy right here. The triangle equals b squared minus 4ac. Now this comes from the quadratic equation. If you remember the quadratic equation, that is where x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So that right there is a discriminant. And what this lets us know is how many real solutions we have. So let's look at an example. We'll look at these three graphs. They all have the same axis symmetry at x equals 1. So you click it right here. Y equals x squared minus 2 minus 2 minus 3. They all have the same axis symmetry. But they have different discriminants. So the discriminant is b squared minus 4ac. It is in your formula sheet. We're going to sub in our a here would be 1, b would be negative 2, and c would be that. In this case, we got a positive, and on the graph we have two x-intercepts, here and here. So positive value, two x-intercepts so far. Say cos x equals y. I'd like to say we have two real solutions. And then look at this example here. Same axis symmetry, but when we do the discriminant b squared minus 4ac, we actually get 0. And in that case, we only cross that when we have one x-intercept. So we have one real solution. And then in this third case here, same axis symmetry, we do discriminant on this guy, and we get negative 8. And if you notice, your graph does not cross axis symmetry. This always happens, so we have 0 real solutions. Remember, a solution is just an x-intercept. A real solution is an x-intercept. So that's what discriminant tells you. Lets you know how many real solutions you have. If the discriminant is greater than 0, then it has 2 real solutions. If the discriminant equals 0, then it only has 1 real solution. Also known as the double root. Because you do have two answers, there's the same answer twice. And then when your discriminant is less than 0, they have 0 real solutions. And that actually tracks with our quadratic formula. Right, when this is positive, I get a plus and minus of a positive number, so I get two answers. When this is 0, that goes away, you just have the one answer right here. And when this is negative, you get an imaginary number. So you get two imaginary solutions. So that's where it tracks from. So again, this is in your formula sheet right here. So what the formula is. This next part, understanding what it means, you have to know yourself. So you have to know that when the discriminant is positive, it's 2 real. When the discriminant equals 0, it's 1 real. And when the discriminant is less than 0, it's 0 real. A good way to tell when a quadratic is positive or negative is when you have 0 solutions. So the discriminant is less than 0. So we have 0 real, right? In that case, look at our graph. You're either going to be all above it or all below it. So then you know the quadratic is always positive, always negative. So first thing has to be is no real solution, so the discriminant has to be less than 0. And then you just check the a. If a is greater than 0, then it's going to be all positive. If a is less than 0, right, your linear coefficient tells you how the graph opens up or down. So if it's positive, my graph opens up. If it's negative, my graph opens down. So as long as the discriminant is less than 0 and my a is 0, it's always negative. So again, this is just telling the quadratic itself. The quadratic itself is either always positive or always negative when you have no real solutions. So if you have no real solutions, quadratics are going to be all positive or all negative, depending on the linear coefficient. Okay, let's do an example. You do the discriminant to determine the relationship between the graph of each function and the x-axis. So again, this is how many real solutions do we have? So my discriminant is b squared minus 4ac. So here's my a, here's my b, here's my c. A would be a 1. First use the formula. 3 squared minus 4 times 1 times 4. I get 9 minus 16, so I get negative 7. So this has 0 real solutions. Okay. Next one, same idea. Here's my a, here's my b, here's my c. B squared minus 4ac. So I'm going to get 5 squared minus 4 times negative 2 times 1. So 25 plus 8. So 33. So in this case, I have 2 real solutions. So like that. If I want to show that this thing is always positive, so the quadratic is always positive. So remember what I said before? First, you got to show that the discriminant is less than 0, and that if I want it to be all positive, that a should be greater than 0. Well, that part we have already. My a here is 1, so 1 is greater than 0, so we're check. So all I got to do is show the discriminant less than 0 and then mention the fact that my thing is positive. So here's a, b, c. b squared equals b squared minus 4ac. So I get negative 3 squared minus 4 times 1 times 6. 3 squared is 9 minus 24, so I get negative 15. So the discriminant is less than 0, so there's no real solutions. And I would say the discriminant is less than 0 plus a is less than 0, so a is greater than 0. So this is always positive. So discriminant less than 0. So something like that. Last example here. Find the values of k for which the function has cuts the x-axis twice. So remember, that means you have 2 row solutions. Touches the x-axis, you have 1 row solution. Or means that you have no row solution. So on here, my a is 1, my b is negative 6, and my k is c. My c is k. So we're just going to set it up. Now again, when you have 2 rows, that means your discriminant should be greater than 0. So we just set up the discriminant and set it greater than 0. So I'm going to get negative 6 squared minus 4 times 1 times k greater than 0. So I get 36 minus 4k is greater than 0. Now I just got to solve this. Divided by negative, so I got to switch my inequality, and I get this. When k is less than 9, I have 2 row solutions. Next one, you want 1 row, that's when it equals 0, so we'll set the equation up. I actually already know what, let's start from here, right? Because I already know what that is. 36 minus 4k equals 0. Then we just solve this. Divide by 4, k equals 9. When k equals 9, I have 1 row solution. And then finally, when it misses the x-axis, that means that the discriminant should be less than 0. You have no solutions. So again, we already did all the work already. We know what the b squared minus 4ac squared is. It's this guy. But this time, I want this to be less than 0. So I'm just going to do the same thing I did last time. Move that 36 over, divide by negative, and now it switches the opposite way. So there we go. That's the lesson.